All right, that is just carbon branches. All right. Shh. Now we're gonna look at cycloalkanes. What do you think the word cyclo means? It's like a circle, or it connects. All right. So they form closed hydrocarbons, if you want to call them that. So if I say cyclobutane, oh, it's frozen. Cyclobutane. Okay. What is butane? How many carbons? 4. We're cyclo, so they are all connected. How many carbons how many bonds does carbon want to form? 4. So you have to have 2 hydrogens on each of these. Now that is the correct structure. It's annoying to draw it that way. Okay. You could draw it like this. They're all CH2s. You draw it like that. I don't even really like that. The easiest way for cyclic ones is the skeleton one. Because what is it going to form? That's cyclobutane. All right? This is the little square. Remember, every corner is a carbon. And you don't show the hydrogens in the skeleton formula. Cyclopropane. Propane is 3 carbons. So you could do this. And then have H2, H2, H2. You could do that. Or you could just draw a little triangle. Okay? Triangle's obviously easier. All right? One thing about certain cyclic compounds, this is propane molecule is falling apart. This is propane, right? 3 carbons, hydrogens. It's happy. Single bonds spin. Okay, so that's why it doesn't matter if you put the methyl groups up or down because they fall apart. But single bonds spin, right? But as soon as you take these and you drop that and that, and you form cyclopropane, you do this, it doesn't spin anymore, okay, because they're all locked into place. Also, it took force to do that, right? That applies to actual chemistry as well. Cyclopropane was discovered in the 30s or something. They used it as an anesthetic. It's one of the first anesthetics. The problem with it was these bonds are not fully stable because they're at a what's the angle of the bonds? Think about math. What type of triangle is this? It's an equilateral triangle, right? So it's 60 degrees. Those are pretty small bond angles. They're not happy like this. All right, so this is an unstable molecule. And so it's actually quite flammable. So if you are putting this into somebody and there happens to be a spark or whatever in the operating room, it flies open, releasing a whole bunch of energy, and that ain't good for the person. Okay? So they don't use this anymore. Yes. It would probably wouldn't be enough to blow them up, but it wouldn't be a good time. For lack of a better term. I don't know exactly what would happen, but there would be an energy release, not enough to probably blow you up. That would be. Did you say we can test it? No. It would just make them unhappy. Okay? So they don't use cyclopropane. Anyway, okay. A lot of compounds, especially when you get into hormones and stuff like that, testosterone, things like that, have aromatic compounds in them. Like don't draw this, but the base structure or cyclic compounds, the base structure of testosterone, see if I can remember this. I forget it. Anyway, is basically got cyclic compounds. Okay? I can't remember the exact structure of testosterone. I'll look it up. All right. How do you name cyclic compounds? So you have to have the word cyclo in it. All right, that indicates that it's cyclic. The word cyclo comes before the parent chain. So you look at the chain that is cyclic. If you look at this one, 1, 2, 3, 4, 5, 6 carbons. Okay. Six is what? Hexane. All right. So this is going to be cyclohexane. Is going to be the base name, the parent name, I guess I should say. So we're going to get then you start numbering. All right. You can go counterclockwise or clockwise. You always want the lowest numbers possible. So start with where there is the substituted group. So we have this, the base ring is the hexane. We'll start here. Call that 1. Am I going to go clockwise or counterclockwise to get the lowest number? You're going to go clockwise because you're going to go 2, 3. If you want the other way, that would be 1, 2. Whoa. 2. Oh my gosh. 2, 3, 4, and then you get the 5. So you don't want to do that, okay? So you still want the lowest numbers. So we number it that way. So what is the name of this? On carbon 1 and carbon 3, we have what group? A methyl group.
Good morning, Robe. Sorry for the interruption. If Bunty Bonifacto is in the building, please come to the office. Bunty Bonifacto, please make your way to the office. Thank you.
So it'd be 1, 3, what? Not methyl. It has to be, you have 2 methyls, so you have to say dimethyl. Oh my. Dimethyl cyclohexane. So it's the exact same thing you've been doing, except you have to put the word cyclo in front of the parent molecule. Okay? Second one. This one. What's the ring? How many carbons are in the ring? 6 carbons. Right? 1, 2, 3, 4, 5, 6 carbons. So that's going to be what? Hexane. So it's cyclohexane is the base name. All right. All right. Okay. We got an ethyl group and 2 methyls. Which comes first in the naming, ethyl or methyl? Ethyl. So we'll start here with the numbering. That's going to be 1. Which way am I going? You always want to start with on one of the substituted groups, right? Because that'll give you the lowest number. If I started numbering here, right, that would be carbon 2, 3, 4, 5. So I'm going to get higher numbers. So pick a group, and then that's where you're going to start. Okay. So if we go 1, 2, 3, what is it? 4? 4. So if I did it this way, I'm going to get, hang on before you write this, okay? 1 ethyl, 3, 4 dimethyl. So 1, 3, 4, right? Are my numbers. if you start here, 1, 2, 3, 4, I get 1. I'll write the whole thing out. 4 ethyl 1, 2 dimethyl, blah 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 blah. So I got 4, 1, and 2. Which way should I number it? Which has the lowest numbering? 1, 3, 4 or 4, 1, 2? Look at the numbers. What's 1, 3, and 4? 8. What's 4, 1, and 2? Which way should you do it? What do you always want? The lowest numbering, right? Right? So look at those numbers. We're going to do that. Okay? So we're going to go, whoops. For ethyl 1, 2 dimethyl, was it cyclohexane? Cyclohexane. All right. Are we good for that? For naming? So you look at the root, cyclic, put cyclo in front of it, number in the lowest way possible. Yes. It should be a dash. Sorry. Commas between the numbers, dashes between the words and things. All right. Sorry about that. Okay. Drawing it, I think, is easier. So cyclopropane, the root. What shape do I draw? It's a triangle, right? Because it's 3 carbons. So you can do that. 1, 1 diethyl. So where do you put the 2 ethyl groups? Sorry? Nope, it would just be on one of the carbons, which are the corners. It's on carbon 1. What is carbon 1? It can be any of them, right? So you could put it here, ethyl, CH2, CH3, and it's on the same carbon, CH2, CH3. But you could draw it this way. Or you could even draw it on the other carbon, because those are all the same molecule, right? Just if you turn it and flip it and stuff, you get the same molecule. So it doesn't actually matter. 1, 2, 3 trimethyl cyclobutane. Sorry.
On that one, you said on the skeleton structure, there's no hydrogens. So
Well, you can put the hydrogens, you just don't draw them, like in a skeleton. But there's technically hydrogens there and there, like that. Is that what you're talking about?
if you're gonna put 2 carbons, right? Would there be
Oh, you're talking about if I do the whole thing skeleton? It would look like this. Okay. Sorry. Yeah. I just drew them that way just to represent it. But yeah, that you would just draw them like that. Okay. All right. Cyclobutane, 4 carbons, square. 1, 2, 3 trimethyl. Just pick a place to start numbering. Doesn't matter. That could be 1, 2, 3, 4. Okay. 1, 2, 3 trimethyl. So 1, 2, 3. There you go. What if you had this? How many carbons are in the ring? 6. 1, 2, 3, 4, 5, 6, right? So you look at the ring, okay? So the ring is 6. So it's cyclohexane. If you only have one group attached to the ring, you don't have to put a number because it's given that it's 1, right? So this is an ethyl group. So this is just ethyl. I should have put it closer. Ethyl cyclobutane. Okay, you don't have to say 1 because it's assumed you're always going to put it on the first carbon. You're not going to say 2 ethyl cyclobutane because then you're starting numbering at some random carbon, right? So it's just ethyl cyclobutane. All right, is that okay? All right, we have to practice. So Hebden 223, 15, and 16, please. There we go. So we're going to add halogens, fluorine, chlorine, bromine, iodine, which have the symbols or the prefix fluoro, chloro, bromo, iodo. And if it's an NO2 group, which I know is not a halide, but the same rules apply to it, we call it a nitro. It's the exact same. Okay, you know how to do this. All right. A lot of these things with halides on them are very toxic. All right. So for the environment and for you, so we got freons. Have you heard of freons before? Which mess up the ozone layer and stuff, which are chlorofluorocarbons. Teflon in your pants is poly. What does poly mean? We do it in math. Many, right? So there's a whole branch of chemistry called polymer chemistry, where you take groups and you just string them together and you get these big, long, massive molecules. That's polymer chemistry. This is poly. Tetra. What does tetra mean? 4. Fluoro. So it's got 4 fluorines. F, which is ethane, 2. And then ene, we'll learn what that means. That means a double bond. All right. All right. All right. Let's just look at the naming. So here we go. First thing you do when you're naming, find the longest chain. What's the longest chain in the first one here? 1, 2, 3, 4, 5. There's only one long chain. So what's 5? Pentane. We have a chlorine and we have a bromine. Which end are we going to start naming these from? The left? It goes alphabetical. So bromine has to come first, right? So we're going to name from this side, or start numbering from this side. 1, 2, 3, 4. So we go 2 bromo, 4 chloro, and then how many carbons? 5, so it's pentane. All right, next one. How many carbons? What's the longest chain? 3, right through there. Boom. This molecule has symmetry, so it doesn't actually matter which side you start numbering from, right? It's always going to be on number 2. So 1, 2, 3. So it's going to be 2, 2, what? Dichloro propane. So the exact same, except we're instead of putting 2,2-dimethyl, now we're just adding chloros and bromos and iodos. All right. 1,2-dichloroethane. Ethane's how many atoms? 2. So if you're going to do the skeleton, basically it looks like that. Just a line. This is the skeleton one. I'll draw the other one in a sec. And it's 1,2-dichloro. So Cl, Cl. You could draw it like that. It's probably easier if it's something like that, is just to just go CH2, CH2 with a chlorine and a chlorine or something like that. The next one, 1,2-dinitro-cyclohexane. Cyclohexane. How many carbons? 6, and they're all connected, right? So you get a hexagon, a cyclohexagon, or a hexagon, I guess. Not a cyclohexagon. 1,2-dinitro. Nitro is NO2. Okay. Put them on any carbon. It doesn't matter. They're going to be side by side. So NO2, NO2. But you could put them anywhere. Right? You could draw it like this. The convention would be to draw it like this. That would be the convention, but it doesn't actually matter. Those are all the same molecule. Sorry? I can't hear you. What? Oh, the second one is the convention. Usually you put it at the top. 1,3,3-triiodoheptane. Heptane is 7. So skeleton 3, 4, 5, 6, 7. 1,3,3-triiodo. There's a skeleton, or they would do it like this. Like that. That'd be the convention, the bottom one, to draw it like that, with them looking like that instead of the top one. Top one looks a little weird. But if you're going to do the other method, you're going to go one, two, three. You do that. And the last one for today, 1-bromo-2,2-dimethylpropane. Propane is 3. 1-bromo, so let's get a bromine. 2,2-dimethyl, so then we've got CH3 groups. Propane, so finish everything off. Like that. If you're doing the skeleton, it would look like that. All right. I would encourage you to do 17 and 18 on the same page as you did before. Tomorrow at the beginning of class, I'll have a few of these to practice, and then we'll move on to, I think we're doing double and triple bonds next, which are enes and ines. That'll be fun. And then isomers, and then aromatics. And we will do a soap lab at some point.